In this video, we're going to learn how to name simple acids. Now, before we start, let's be clear on the definition of the word acids. Let's make sure we know what we're naming here. An acid is any compound that releases hydrogen ion in solution. So an acid, by definition, can release hydrogen ion in solutions. Chem 202, you'll see that we can expand this definition, make it more general, but let's keep it simple for now. So what would be an example of an acid? Here's one. When you put this into water, it will react with the water. And what will happen is this hydrogen ion that's inside here will come off and stick onto the water. When you take the hydrogen ion off of this and stick it onto the water, you get H3O+. And what's left behind then will be a chloride ion. So that's the reaction between an HCl molecule and water. This thing is acting as the acid because it is the thing that is releasing the hydrogen ion. The thing that accepts the hydrogen ion is called a base. And there's the base with the hydrogen ion accepted onto it. It's stuck on there now. And this broken acid that's left behind, it doesn't have its hydrogen ions anymore. This thing is called an acid anion. It is a negatively charged ion that was embedded originally inside the acid. So there's some vocabulary here for you. You should be able to define acid, define base, and define acid anion. It is the negative ion that it was inside of an acid. It is what's left behind after you pull the hydrogen ions off of an acid. Now, I spent some time showing you this because in order to name the acid, you have to first name the acid anion. And let's do this for a couple of acids. If I have HCl, the acid anion is Cl-, which is the chloride ion. So you can already name these ions. We've done this already in previous videos. What about this one? What's the ion that's inside? Now, you should recognize from the polyatomic ion list that you've memorized, right? That this is a sulfate ion that's inside here and that it has a -2 charge. But suppose you didn't memorize that. You still could work it out. The leading hydrogen ions here, there are 2 of them, each have a charge of +1. So if you pull off an H+ and then another H+, you have left behind SO4 -2. And from your polyatomic ion list, that's a sulfate ion. How about this one? If you pull off the hydrogen ion on the front, you have this ion left behind. Now what would that be called? On your polyatomic ion list, you don't have NO2-, but you do have NO3-. That you know that one's called a nitrate ion. So what would this one be called? We talked about some rules for adjusting the ion that you know to make ions that you encounter. What we have done here is take off one oxygen. So what do you do with the name when you take an oxygen off? If you look back at your polyatomic ion, prefixes and suffixes, you'll see that this is called a nitrite ion. So all the stuff that we did before about naming ions, you'll need to know to be able to do this job. If you do not have the names of the ions, if you cannot rattle these things off, go back and study that again. Alright, so once I have the names of these, I can turn them into acid names. And here's how it works. I'm going to look at the ending on the anion name. And that's going to give me how to build the acid name. For example, if my ending is an IDE, I name the acid by putting a hydro in front of the name and an ic acid on the end of the name. For example, let's name the one that we have up here. Here I have a chloride ion. If I take off the IDE and I replace it with a hydro up front and an ic acid on the end, I will have hydro chlor ic acid. See? So suppose I have this acid. The ion inside that is a Br minus, and that's called a bromide ion. Remember, we put an IDE ending on the end of a negatively charged nonmetal elemental ion, and it's got an IDE ending on it. So this would be hydrobromic acid. Here's the acid that Walter White uses in Breaking Bad to dispose of bodies. It's a very bad acid because it will dissolve glass, it will dissolve bone, it will dissolve just about anything, except plastic. You've got to keep it in plastic buckets, plastic bottles. So let's name it. The ion inside there is an F minus ion. I can tell that because if I pull the H plus off, there's going to be an F minus left behind. That's called a fluoride ion. And this would be called then, since it has an IDE ending, hydrofluoric acid. Okay? So that's how this first rule here works. Now, not all of these have IDE endings. What happens if you have an 8 ending? If you have an AT ending, you don't put the hydro on, you just put the ic acid on the end. So, if I want to do that second acid up there, H2SO4, the ion inside that is SO4 minus 2, we said, and we said that's called a sulfate. So what I'm going to do is cut the 8 off and put ic acid on the end of the name. Now I would think that that would be sulfic acid. But that sounds kind of funny, sulfic acid. So what people do is they'll put a UR in there and they'll call this sulfuric acid. So some of these are pretty irregular. You don't just chop off the ending and put an ic acid. You make it sound good. All right, what if we have this acid? This is the acid that is in carbonated cola drinks. It's there as an acidulant. People like kind of a tart acid taste in a lot of their food. The ion inside there is, can you guess what the charge on this is going to be? Even if you don't know your polyatomic ion table, what would the charge on a PO4 be? Well, you reason it out like this. You're going to pull 3 H pluses off of this. And that means that there has to be a PO4 minus 3 left behind. From your polyatomic ion list, what's the name of this? That would be a good test question. It's phosphate. So what do we call this? I would cut the ATE ending off and replace it with ic acid. So I might think phosphoric acid. But that sounds kind of funny, phosphoric acid. So I put phosphoric acid. That's phosphorus in there. So I'm really kind of using the element stem, the name of the element in here when I am making these names up. So this is sulfur, I put sulfuric acid. This is phosphorus, I put phosphoric acid in there. It's a little bit irregular. All right, it isn't entirely straightforward. I would remember a couple of these common acids, just how it works. All right, one last thing and then we're done. If I have an ITE ending, I am going to replace that with OUS acid. So instead of ic acid on the end, I'm going to put OUS acid if there's an ITE on there. Now, here is an acid that you will find sometimes in dried fruit. Now, let's look at the ion that's inside there. If I pull two H pluses off of that, the ion inside there is going to look like this. Now, we don't know this ion. It's not familiar to us because it's not on our polyatomic ion list. But sulfate is on our list. And this has one less oxygen than sulfate does. And we have a rule. If we want to put one less oxygen in something, I can put an ITE ending on that. So this is a sulfite ion. So that means that I'm going to take off the ite and put an OUS. And this will be sulfurous acid. What about this one up here? What would this acid be called? If this is a nitrite ion, I'm going to take the ITE off and I'm going to call this nitrous acid. Is what that one will be. Now, drill yourself on these. Give yourself a bunch of acids and see if you can work out the name. Here's the step-by-step process. You look at the acid, figure out what's the formula and charge on the ion that's inside. Ask yourself, do you know the name of that ion? And then the next step is, look at the ending on the name. If it's 8, you're going to cut off the end and put ic acid. So this would be called nitric acid. That's the process that you go through to name acids. Do as many examples as you can stand to do.